Hello teammates, it's Mr. Nani coming to you with the solution to FRQ number 8. So I'm going to do these like this, I think, for the rest of our time together. And I'll let you know if I use AP Classroom again. But I think this is because I'm going to write these on my own. And like you saw in my note, it's I got more flexibility to write on this in AP Classroom. It's good. So we got electron moving projected this way, and it's going to go through this slit. We're asked a couple things. I'm going to go through this kind of quick and dirty, just key points. I'll post the key. I will post the key on Schoology. We want to identify the electric field inside the box. So the electron. So if you use your right-hand rule, your electron is going to be moving vertically. The magnetic field is into the plane. So a proton would feel a force to the left. An electron is going to feel a force opposite. An electron is going to feel a force to the right. So you want that electric field to be to the right as well, because you've got your positive charges here and your negative charges here. Electron is going to be repelled by this, attracted by that. So if those forces are balanced, the electron is going to pass straight through. We did a problem like that right at the end of the magnetism unit with the velocity selector. Very similar. I got some dialogue there. So that was 2 points. Identify the direction. And I'm trying to give you a flavor for what these should look like. Teammates on the exam, you know, they don't just want to see a sentence or two, right? Unless it's just obvious a sentence can answer the question, right? If you answer the question, you'd be given 20 minutes. If you're done in 12 minutes, you did something wrong. Go back. I got some tips for you. Identify electron speed. It's the velocity selector problem, isn't it? Force electric equals force mag. They give you E for the charge of the electron. Use E. No reason to use Q. Q's on your equation sheet. They tell you it's E. You're going to use E. E field, charge, velocity, mag, earth, sine, theta. Use the whole equation. Then identify the field is perpendicular to the motion. Sine 90 is 1. You can ignore it. Solve. Your velocity is E field over magnetic field of the Earth. They identify it as B Earth. You're going to use B Earth. And that's my note. Use what they give you. Identify the magnitude of the acceleration as it leaves the box. So the instant it leaves the box. They're not looking for a centripetal force here. Now on the guide, they said you could answer this with centripetal force, but the math gets a lot. The variables gets a lot different. So you're gonna say at the instant it leaves the box. Application Newton's second law. You're gonna write Newton's second law. By Newton's second law, force equals force mag. Outside the box, the only force acting is magnetic force. You're told you can ignore gravity. You're going to go variable by variable. You're not going to jump from here to there. You're going to divide force is mass electron A equals electron's charge velocity B field Earth. You're going to solve for A. Easy money. Easy money. Use their... They say mass electron, use mass electron. You could also sub in. You identified in the part above, velocity equals E field over B, Earth. You can also sub in your velocity, and you get something like that. Acceleration equals charge, E field, mass the electron. You must be clear. That the magnetic force is captured in your derivation. So you got to walk through this step. right? Because that's what's giving you that force, the magnetic force. If you just throw that out of your equation, you're not going to get the point. The last one, I thought it'd be fun. I threw this one in the very last minute. Identify how the Earth's field can be represented in the diagram at the top. So you know, and maybe you don't know all this. Now you do. The solid core, the liquid core rotating, they rotate at different rates. That generates the magnetic field. So right, because moving charges generate an electric field. So those electrons in that, so that the solid iron core is rotating, the liquid iron core is rotating. The liquid iron core is retarded a little bit, and that's a scientific term. I think it's terrible. We can't use that word anymore. But is slowed down, and so you've got a difference in motion, and so you've got a difference in velocity of those electrons, and that's going to generate your mag field. And so your mag field goes actually right from the South Pole to the North Pole. So the Earth's geographic South Pole is actually the Earth's magnetic North Pole. And the Earth's geographic North Pole is our magnetic South Pole. Isn't that interesting? And so again, you look at those field lines coming across, that's exactly it. So if you look at those field lines coming from south to north, they're going to pass through, and that's how that field comes to be. I thought that'd be something worth knowing. All right, teammates, quick and dirty. I'll post the key. If you got questions, I got answers. Have a great day.